Hello students. Today's class we are going to discuss about the first topic in analog and digital electronics called transistor. Why the name transistor? We are going to discuss about transistor. It means that transfer plus resistance. It transfer resistance from one place to other. That is one end to other end. That's why this is called transistor. Normally, transistor is classified into two types, BJT and UJT. It means that bipolar junction transistor junction, this is uni junction. Okay, now we are going to discuss about elaborately BJT. BJT further classified into NPN transistor and PNP transistor. Before enter into the topic NPN and PNP transistor, we should know about some technical words: doping, forward bias, and reverse bias. In your 11th and 12th standard, you people studied about the semiconductor. P-type semiconductor, N-type semiconductor. What is normally semiconductor divided into two types: intrinsic semiconductor extrinsic semiconductor. What is intrinsic semiconductor? A pure semiconductor is called intrinsic semiconductor. To make a semiconductor, to do a conduction process, we should add some impurities to the intrinsic semiconductor. If you are adding P-type material with the intrinsic semiconductor, that is called P-type semiconductor. If you are adding N-type impurities with the intrinsic semiconductor, that becomes N-type semiconductor. So depending upon the impurities we have added to the intrinsic semiconductor, we can call it as P-type and N-type. The P-type impurities are a trivalent impurities. Trivalent impurities. N-type pentavalent impurities. Okay. So what is doping? So doping is a process of adding impurities to the semiconductor to make the semiconductor involved in the conduction process. What is forward bias? Forward bias means if the P-type material is connected with positive and N-type material with negative, that is positive to positive connection, negative to negative connection, is called forward bias. What is reverse bias? What is reverse bias? Positive to negative connection and negative to positive connection is called reverse bias. So, in this introduction class, we discussed about what is transistor. Transistor is nothing but transfer resistance from one end to other end. It basically divided into BJT, UJT. Then Under PJT, we are having two types, NPN and PNP. So if you are going to discuss about NPN and PNP, we know N-type, that is semiconductor, is framed by adding some impurities with the intrinsic semiconductor. P-type semiconductor is formed by adding some P-type impurities with the intrinsic semiconductor. In a PN junction, if you are adding one P-type material here, it is PNP transistor. In a PN junction, if you are adding one N here, that is called NPN transistor. Okay. A transistor consists of three terminals: emitter, base, collector. What is emitter? It emits the charge carriers. That's why this name called emitter. What is collector? It collects the charge carriers emitted by the emitter. Okay. The base is nothing but an intermediate path between the emitter and collector. When you're now we said that emitter emits charge carrier. We are talking about the charge carrier. If it is a P-type material, what are the majority carriers? If it is a P-type materials, majority carriers are holes. Minority carriers are electrons. Minority carriers are electrons. If you are considering a N-type material, what are the majority carriers? The majority carriers are electrons and the minority carriers are holes. So, emitter is nothing but emitter emits charge carriers and collector collect whatever the charge carriers emitted by the emitter. Okay. Now, we will discuss about the BJT construction, how the transistor is constructed. Construction of construction. So, we already know a BJT consists of three terminal N, P, N, emitter, base, collector. Basically, if you are talking about the doping of this emitter side, this first N side, emitter side, the doping is, already we said doping. What is doping? Doping is adding impurities. The process of adding impurities is called doping. So in emitter side, the first N-type width is, so here doping level is very high. Here the emitter side, if you are talking about the emitter side, emitter doping level is very high. Okay. Why the doping level is high? Because it is going to emit the charge carriers. So the collector, when you are talking about a collector, the doping of collector is very low. Why it is very low? Here it only collects charge carriers emitted by the emitter. Okay. For a base, we no need to discuss about the doping. It's just an intermediate between the emitter and collector. Then we are going to discuss about the width of this emitter base collector. If you are talking about the width of the emitter this side, considering the width, it is having a width of very moderate width. For emitter, the width is moderate one. But you are talking about the collector, its width is very high. Why? Because it is going to collect all the charge carrier emitted by the emitter. That's why it's need a width of high width. We are talking about the width of this layer. Then if you are talking about the base width, there is no need of high width. It is just a path between the emitter and collector. Imagine that if you people are traveling from one place to another place, if you are traveling in a lengthy distance, your loss will be your energy will be reduced. So the same way, if you are the charge carrier is moving from emitter to collector, if it's traveling in a very high distance, there is a chance to loss of energy of the electrons or charge carriers. Hence, the width of the base is very thin. So, if you are really see the construction of this any one BJT transistor, so its width is moderate one, its width is very thin one, N, P, N, like this one. This is about construction. Once again, I am explaining about the construction. This is PN junction 1, PN junction 2. So each emitter BJT has two junctions, junction 1 and junction 2. It has three terminals, emitter, base, collector. When you are talking about the doping level of the emitter, the doping is very high because it is going to emit the charge carriers. The doping level of collector is very low because it only collects the charge carriers emitted by the collector. We won't bother about the doping level of base. Then if you are talking about the width of that layers NPN, so emitter has a moderate width and collector has a very high width because it is collect all the charge carriers emitted by the emitters. When you're talking about the width of the base, it should be thin because it's just a path between the emitter and collector. Thank you, students. We will continue in the next class with the working of the BJT. Thank you.